Welcome, everybody. You're listening to Humans Talk, a podcast about ideas, systems, and the people who live through them. Each episode invites you into a conversation that's unscripted, curious, and designed to make you think, feel, and imagine differently. Let's begin.
Hello and welcome back to Human Stock. In part one, we started with balloon internet, but that turned into something much bigger. We got into self-replicating 3D printers, space elevators, autonomous mining, even the possibility of walking on Venus. Today, we're picking up right where we left off, with the rest of the tech lineup, some wild new concepts, and maybe a few more world-bending ideas along the way. So let's get into it.
All right. Sounds good. Yeah, so we have a wide-ranging technology profile of Project Human City. Um, like we mentioned last time, we kind of had two anchor points. First was the balloon internet to offer accessible internet, and then the Arc Cradle one for space exploration, but also advanced material fabrication on Earth and like in space. And these kind of open up a suite of technology and different products that we can use in our day-to-day life. And so we've like off of the base capacity of the Arc Cradle 1, we looked at a huge product line. And so some of them we got into, some of them we don't, but we'll go through all of them. One of the first ones off the bat, we talked about a world train project, a maglev train that actually goes all around the world. And so that concept in and itself is called the bubble train. And so the cool thing about that is it uses graphene and other composites to make incredibly light trains, and also to coat the components of the maglev propulsion system to keep the train, going forward. We've integrated energy feedback collection systems. So, for example, as a train goes into a tunnel, we design the tunnels to incrementally collect the wind energy from the actual like displacement of wind of the train going through it. In some places, we looked at how we could use tactile pressure plates of the weight of the train to produce energy. And then overall, like parts of the train track that would be covered in tunnels, we looked at covering them with solar panels so that we get a immediate return for the electricity that we're expending to propel the trains. And then, so the novel thing about that is we were looking at, or not necessarily the novel thing, but the thing that leads to other technologies was if we're going to build a world train system, we'd have to bore tunnels. So that opened up the Trishula drill system, which is a three-part drill system. One of the drills is aimed to work on land as a vertical drill for holes for the train. Then another drill was designed to burrow deep into the planet, and we've kind of talked about that in the last call. And then the third type of drill, which is it's a little bit of an out there idea, but the idea was to how we could mitigate flash floods from space. So the idea was there. Idea was if we could drop drill bits, like actual massive drill bits from the upper atmosphere and control the rate of descent of the drill bit, we would be able to, in places that are experiencing massive flooding, we would be able to deploy a drill bit from the upper atmosphere and have it bore about half a kilometer into the surface of the Earth and immediately create a sinkhole to rectify situations where the flooding was unmanageable. And then that looked at a system of after we had to drill these drill holes, how do we turn them into cisterns, a cistern system for those cities? And that was like more of a very emergency situation because A, you'd have to stop the drill bit from descending too fast, and have to counter the spin of it, and then also control the spin so that it is going fast enough that it actually makes a hole, but not too fast that it's creating like an earthquake or a fissure in the actual earth as it impacts. So we looked at some scenarios that would allow us to do that, but that's more of a experimental angle of that drill system for sure. Definitely, we're just looking mainly for burrowing holes for the maglev train system, and then potentially how we can use advanced drill bits in space mining and space exploration. And I kind of
But how would
mentioned,
you, sorry to interrupt, how
mm,
would you keep the drill stable, like as it falls? Um, you know what I mean? Like, wouldn't it just spin like out of control if you're throwing it into the
by
earth
actually
like that?
the spin will help stabilize it to some degree. Also, the distribution of weight, so that it doesn't teeter and it can't get like knocked off course.
Ah, I see.
And then we also putting in fins and reverse thrusters to actually like thrusters pointing down to slow it, and then make those thrusters directional so that they could be like pointing out at like a 45-degree angle to slow it. And then when it gets to the ground, turn them facing up to further propel it down into the earth.
Hmm.
Yeah, but
So
that's
it's kind of just creating like a pressure. So it like in anything with it's like it wouldn't deploy like and it'll just be creating like a pressure hole.
yes.
Mm.
And then for the water to dissipate into or collect into, and then it'll like that requires us to A, map the locations in advance and understand the infrastructure underneath, right? You don't want to
Uh-huh.
break a subway line or something like that, or stuff like that. So it really depends on the areas that you can actually deploy these systems. And then it also look at um, how that point of entry can be turned into a long-term water cistern for that community, because then we're assuming that if they're getting a massive flash flood, that's like probably a 100-year event that has been moved up to like happening every 5 or 10 years, then they're going to need the infrastructure to build cisterns, right, for their underwater storage capacity. Think of like if you've seen the massive underwater caverns in Tokyo, they have like massive a storm water system under Tokyo that is supposed to handle all of the water in a flood event. The idea is to replicate that in an almost emergency sense, in a pragmatic situation, because these places obviously haven't developed the infrastructure to have cisterns in the first place to mitigate their wastewater in these events, right?
Mhm.
So it is a very emergency situation type of deal, but it's definitely something we want to look into.
What about
Um,
for earthquakes? Like as
Earthquakes,
far as
yeah,
like
that
drilling?
it does make me worry, and it was a point of concern of causing earthquakes.
Yeah.
And that can definitely happen because even fracking causes earthquakes. So massive disruption to the soil and the ground in general may cause disturbances, may cause deeper fractures. Um, it depends on how, we might have to do a test case, but it depends on how the layers of underground strata deal with the influx of water um, coming in. So it's like, is the water going to seep out into the water table horizontally as it flows into the hole? And are we just getting past like the semi-permeable or non-permeable cement layer, right? And then allowing the water to naturally drain into the water table?
Mm.
Or if creating this puncture mark, does it disrupt a more stable foundation and then create fractures? And I think the risk of earthquakes more depends on the pressure of the water going into the cistern and
Hmm.
displacing, right? So if we're like if the hole is deep enough to hold all of the water without um like if it's deep enough to hold all of the water, then it will naturally seep into the rest of the groundwater. If it's like, even if it isn't fully deep enough to hold all of the water, you're not going to have the issue with pressure as much that you get into fracking because we're not applying a pressure to the water to go
Hmm.
into the hole, right? So I think that mitigates most of the risk of earthquakes. As opposed, like you do have to also understand where fault lines are, because it's like you can't just drill deep into the earth and maybe hit a fault line that could be disastrous, depending on like if there's magma under the ground or something like that, or if the plates are particularly thin in that region. And then it may create alternative chain effects. But that actually ties into another project overall. It's the ISEP, I think, but it's a international standardized environmental platform,
Hmm.
and that project was looking at how we can use AI to create replicated models of the world. So like a second world, like a virtual world that we could conduct these experiments in. And that was actually one of the first projects that we're going to aim to do once we gain funding, so that the later technology that we're introducing, we can test it out in a virtual environment before actually deploying it in the real world. Um, the
Hmm.
ISEP system, it looks at the world by layers. So like the soil layer, the urban layer, the different layers of the atmosphere, lithosphere, stuff like that. And it allows us to amalgamate open data sets and then also collect citizen data and construct a more composite model of how our actual world is functioning at the time. That actually goes into like a deeper idea of Project Human City, that in order to create massive change across the world on scale, that we have to conduct a world inventory and properly understand all of the resources that we have as a species. And so like the ISEP project was a way of creating an open source framework for different nations, businesses, and individuals to create that inventory in a
Hmm.
virtual environment and then allow us to run calculations or simulations on interventions like the drill system.
Hmm. So then the goal is eventually like having communities there. They're basically able to add their like local data into one system where
Mhm.
everybody's contributing into it.
Yeah, and that could also like turn it into if we revalue how work is valued, that could also turn into a career where people are tasked with just collecting as much information about the natural world as they can and archiving it and having it compared against the empirical experiences of other people,
Hmm.
um, to like test the data. Like, so example, if your job is to test the water in a stream, and then you can have IoT points like actual digital thermometers to bounce that data off of and get verification as well. So it looks at developing that digital infrastructure and that human interaction to build a real world model of the world. But that's a little bit of a tangent, I guess. The next technology that we are aiming to build in this um, array is called superpads. And so superpads is a battery concept to make super small, high capacity batteries by using single sheet materials and using twistronics. So twisting the single sheets to create novel types of circuits, and uh, either reduce energy loss through like superconductive materials like pure copper filaments or ferrocopper filaments. That's the main one we're looking at right now. Graphene, ferrocopper, and copper overall. Um, but the idea there is to um, create cascading events or electron circuits in batteries by folding materials in a certain way so that sheet one and sheet two with different properties can become the cathode and anode of the battery and work continuously.
Mm-hmm.
And like that's a key staple. The next one is called the mob. The mob is a an array um, of robotic arms and infrastructure tools to help construction. So the mob is actually, we took out the tooling in the Arc Cradle 1, and then we're like, okay, if we have all of these different tooling that we need in the chamber, what if we were to put these toolings on robotic arms and give them a sense of sight, a sense of tactile feedback, and then we can take all of these elements that we're fabricating in the Arc Cradle 1 and kind of do it on scale in public. And so we were in that case looking at how do we like 3D print pipes? How do we 3D print wires? How do we coordinate the pouring and formation of concrete in like road situations? So the whole digging up a road, the idea there, we were looking at how to even recycle the concrete at the site when we
Mm-hmm.
dig it up, and use it in like more of a truck type of build to repave the roads, um, and cut down core infrastructure costs for remote communities and communities in general. Um, then the next thing is called the UFO human craft, and that was me
So
being
before
cheeky.
we move to the next one, for the battery, I just have one question on that. Is that supposed to, but like, is it going to give energy to anything, like whatever devices you want to use, or is it
Well,
certain technologies that it's going to power?
the first key use case was like kind of like a Ryobi type of model where like the power tools where the batteries would power different parts of our other technology suite, right?
Mm-hmm.
So, for example, of trying to make the mob and those robotic arms not run without sorry, make it run without a gasoline motor so that they could run purely electric, we would need really high capacity batteries,
Mm-hmm.
right? And so the first use case is how do we use it in our products like that, where we want to deploy a system that is energy draining and we don't want to use gasoline or just like an internal combustion engine to power it. How do we make these things fully electric with a high capacity battery? And then the second use case after that, more of a how we would market it to the public is once we're able to scale a high capacity battery that's able to power these technologies, it's at what scale or at what size is it appropriate, or are we able to make district batteries? So district batteries are bigger batteries for communities that collect solar energy or some other type of renewable energy. How do we scale the small scale high capacity batteries into bigger community um, or bigger district batteries to allow communities to go off grid, being able to store all the energy that they get throughout the day from like solar, and accurately or adequately address their energy needs at night.
Mm-hmm.
So all of like most of them will have some kind of connection into the other products. I'll actually skip the UFO human craft because that was just me being cheeky.
Oh,
It's like,
that one sounded pretty interesting.
oh, it was so that one was us. We looked at we wanted to make a flying car. And so we designed a flying car that was similar to UFOs, like the dish saucer
Mm-hmm.
UFOs. But what it was, it had a main pod and then an outer ring that was connected through gyroscopic gears, so that it's like it had like a ring around a central pod, and then the outer rings kind of moved up and down and side to side, and
Oh,
so it would achieve vertical lift and then like forward
by the
thrust.
wings there that are moving side to side. That's what
Yes.
propelling.
That one we
Can
kind of we didn't backpedal, but we're like um I don't know. I'm kind of bullish on electric cars. I'm not quite sure how I feel about it. Sorry, not electric cars, flying cars. Um
You know,
You
flying
know,
cars, yes, it's good, but what's really bugging me, they still don't have the hoverboard.
yeah. Yeah, no, the issue I have with flying cars is you could do a lot of damage with a flying car. That's pretty much
Yeah,
it.
that's true.
Yeah, I don't want to give people ideas, but like if you're flying in a flying car and you drop pennies out the window,
Yeah.
or or knock on wood, 9/11 2.0,
Oh yeah.
like it's very difficult. Like the risk of that is incredibly high when we allow individuals to pilot them.
Hmm.
We did offer, like when we pitched that we would create a open source um, kind of like aerial road system that would allow these like flying vehicles to be kind of semi autonomous, and we would create lanes in the sky for them to operate. And then the idea would be to make it a open source platform, and then developers of different open source cores could put in controls. Let's say if you went out of the air lane,
Flying zone.
right? Yeah, if you went out of your flight zone or
Hmm.
the flight paths, then we would want to have some kind of mechanism to redirect you into the proper flight lanes,
Hmm.
so that you don't do anything dangerous or nothing happens.
So then, that would also solve the problem. It's like how, at what point do you need a license to fly? Once
Yeah.
you, I guess maybe there's certain zones that you can go to, right?
Mhm.
Past that, you need like a license to fly an airplane.
Yeah, I think maybe we'd have like maybe like a consumer or like a general public layer, and then more of a commercial high stream layer. Personally, and I pitched this to the government as well. I don't believe in personal cars. Like, I don't think people should have individual cars. Um, I think we should. What I pitched to the government was actually developing a national fleet, and the idea was working with car manufacturers, kind of like the idea that Tesla was talking about, where it's like you robo taxi your car,
Hmm.
but the idea was that's just the standard for everybody. So you don't have to buy a car to be in that system. The
Hmm.
nation would supply enough cars for demand, and then
Hmm.
augment that system by implementing the maglev train system, and like having a feed-in system.
Yeah, you
So
just pay like for a streaming service.
yeah, and so
Hmm.
like, and then it would be ideal. So it's like instead of having to do like a cross country drive, like it would recommend like going to the maglev train station and then taking the train across the country and then getting a car where I get out and then
Hmm.
doing the other part of my travel there. So it's more
I
of
think
like
they
first
call
mile,
the whole
last mile.
concept as transportation as a service, TAS.
Hmm.
Or I think they already have in some states where they actually already came up with something, on a very small scale.
Hmm.
They already have these self-driving cars where you kind of sign up for a service or something like that, but it's on a very small scale. I never really looked into it much,
Hmm.
but I don't know if it's the concept that's transportation as a service, or that's the actual that they've already started this idea.
I'm not quite sure, but overall, this is one of like the idea of transportation as a service is why I'm really upset with this whole green revolution and like everyone like vying to make electric cars, is that we're already seeing the capacity for autonomous cars. China has a massive output of cars. It's just not efficient to keep producing cars for individual people to buy. It doesn't make sense.
Hmm.
Even the whole idea that like, when Tesla was talking about, we don't need parking lots anymore if everyone's like robo taxiing and stuff like that. It's like, okay, if that's the vision, why doesn't Tesla tell us when they need to stop making cars, right?
Hmm.
There's going to be a point where there's going to be enough cars for that type of system, and then you're just working on recovery, and the economy isn't set up for that right now. Everyone wants to produce their own electric car. Everyone wants to put out an electric car. And it's like, that's why the lithium is running out because it's
Hmm.
wasteful, right? It doesn't make sense if everyone's trying to put out an electric car when the end goal is an autonomous car fleet that saves energy. Like the car is the battery, right? In the electric car model, that's what we're all told. The car is a battery, it's shifting the energy around. Then why does everyone need their own car?
Hmm.
And they don't. And so we should have a point or a number of electric cars that are autonomous, and then we don't need any more. Or we need a recovery rate, right?
Unless you're rich and then you want like, like today rich people buy a horse and then normal people don't even own a horse, they own a car. But then a
Yeah.
horse is very expensive and you're really gonna use it if you're rich. So I think
Yeah.
maybe one day like a car will be just like a luxury item.
I kind of see that this is a huge problem I've thought because even like as you mentioned, like the luxury item, driving is very ingrained in some people.
Hmm.
There are huge car enthusiasts, and I'm like,
Yeah.
it's almost as like if you say let's take your cars, it's like saying let's take your guns to Americans to some people. So yeah, that's why I'm very skeptical about that issue because I understand there's a deep culture around cars. People love them. It's a sign of your personal identity and your personal freedom, and you're not going to necessarily trade that in right away. So, maybe we'll get to the point where we have like a standard vehicle that everyone uses, right? And
Hmm.
then that reduces the parking lots. It does that whole greenification that we're looking at. But then we're gonna have more like scenic car tracks, right? Kind of like the new golf course,
Hmm.
where you're gonna have a car autobahn through a forest and something like that, and you rent
Hmm.
expensive cars to drive through it. I think
That might
that's
be
where we're
actually
gonna.
even better because for those people that really like to drive, they can't like maybe they'll have like one section where they can drive fast, then one is like
Mhm.
off-road section. So because you got young kids that like to race and they
Mhm.
go and they do it on the street.
Yeah.
And that's these people love their cars and that's what
Mhm.
it's their hobby. They like to race them, they like to upgrade them and race. So that could be a good solution for even, right? Even though they don't really buy it as part of their need,
Mhm.
but they can still live out their passion, I guess, their
Yeah.
automobile passion.
Yeah, for sure. Even that, like when we pitched the UFO human craft, we were like, we could spin this off into like creating supercars and stuff like that. The whole like the whole idea of coming up with electric cars was in response to Mexico's electric car. I think it's called the Olenia or something like that. Or Orania, I forgot what it's called. But essentially they were developing an $8,000 electric car. And we were like to the government, we have the supply chain to match that. We can develop an $8,000 electric car easily in Canada. We have the aluminum, we have the lithium, we have the cobalt, we have the steel. Um, so it just makes sense that we could create a national car like that,
Hmm.
right? So so yeah, that's kind of where it went. Um, next, React Core. So React Core is again folding off of the idea of the super pads, but the idea with React Core was how do we make super small nuclear reactors? This is actually a thing I always say, is that if aliens were ever to come here, if you were an alien to come here, you would have the ability to put um, a whole nuclear plant in the size of a backpack.
Hmm.
Like that's how small you'd have to scale your technology to get here, right? And
Yeah.
then I also say that if you have that ability to make a nuclear reactor the size of a backpack in a society, um, you'd have to have free access to that technology to everybody. And so it kind of plays into the issue of people dropping pennies from a flying car. How do we make sure that people don't use this technology for terrible things? Um, and that's kind of the siloing of resources and the accessibility of technology and resources often create issues in people that, cause them to have antisocial behaviors. So, the lack of community, lack of connection, and lack of transparency in society often drive people to those things. I also often say that conspiracy theories are driven from the lack of transparency in society. So it's that not that there's aliens or anything, it's that people are told that we live in a just democracy. They don't see it represented, and then they have to come up with these conspiracies to rectify the difference between what we have been told and taught about the system and how it should work and
Hmm.
what's in reality, right? I feel like that is the major cause of conspiracy theories. That will be a major cause of technological disasters because of people aligning to conspiracies and the unequal distribution of resources, which amplify these antisocial behaviors in individuals.
Hmm.
But yeah, the whole idea was to use single sheet electron systems to create continuous cascading nuclear reactions. Um, and yeah, Um, the next thing was build to last polymer. So build to last polymer was looking at how we can use things like graphene to make our houses more environmentally insulated. And so a big thing in like Canada has been upgrading our housing stock to be more energy efficient, right? To lose less heat, to retain heat when we need in the winter, to cool efficiently. So we were looking at how we can use graphene coating, which is something that's, or single sheet coating, which is something that's big in the Art Cradle 1, and then take it out into the real world and coat people's houses in like semi-translucent polymers that would keep the heat in, um, could passively collect electricity. So we're looking at also applications of paintable solar panels, which is something that's recently been developed. So it's like, how do we develop spray-based technologies that we can coat the house in and improve the house? So
Hmm.
first one was like a graphene polymer to increase heat retention. And then the second was how do we layer that with like a photoreactive energy collector and then have that two-phase system of the houses keeping heat in, and then the sides that are exposed to light, how are they capturing energy in?
So would this be
And
like a sprayable take type of thing where people can just do it themselves?
I kind of envision it as like the mob doing it. Like, so it would be like you'd rent or call a service, they bring the robotic arm and it would go around your building and spray it.
Hmm.
Um, just because I feel like the solution, like the chemical solution, not like idea solution, the chemical solution may not be stable in an aerosol can for people to just sell it like that. We may have to like heat it or we may have to mix it and stuff like that at the point of application. So keeping it in a machine would help that process.
Hmm.
Um, the next one, we talked about Squishy Boy. Clear Mirror is another one. So Clear Mirror was our idea for phones, for high-tech phones. And so what we wanted to do is create a phone that is like a transparent sheet of polymer, so like a see-through phone. And the idea there is that we could put kind of like the Vision Visage, where I mentioned you have like a graphite sheet and then layers of serrated or raised graphene that shift with electrical charges, doing the same thing to create a display on your phone, and then also looking at how we could use that shifting graphene configuration to essentially create shallow holograms. So shooting lasers from the bottom of the phone. So it might be like a plastic sheet with like a metal band around the bottom. And then the idea is that it would shoot lasers up, get refracted up perpendicularly from the see-through plate, and you'd be able to see small holograms on your phone.
Mhm.
And yeah,
But
the
it's
cloud.
a hologram.
Sorry.
It's like a see-through hologram. Is that what you're talking about? Where, like in the movies where they come up
Hmm.
and then you hear them talking, or like your avatar.
Yeah,
Mhm. So then you'll
yeah,
have like your mobile, and you can just swipe through your mobile, but it's going to be like right in front of you, like a hologram.
yes,
Uh-huh.
yeah. So it'll project the screen out more.
Hmm.
Um, um, the other thing we were looking at is something called the cloud kite system. So we kind of talked about it, but what we wanted to do is, so we talked about like the weather balloons for internet. What we wanted to do is reinvent the rocket ship. And so right now we have like reusable rocket ships, which I'm not really a fan of. And so the idea was to create massive like weather balloons with super material coatings so that it has the same mechanisms as the balloon internet, where it's taking hydrogen, heating it to displace the air around it by either getting hotter or colder. But the idea in the cloud kite system was we put in a flexible lining inside of the balloon, and when it reached an optimal altitude, like the max altitude for buoyancy, which is about 2,000 meters, it would start to ignite the hydrogen in the balloon and rocket propel from that point in the atmosphere. So instead of trying to launch a rocket from the ground, which is going to cost a lot of fuel, the idea was you let the balloon with its hydrogen, which is naturally going to be buoyant, go up as high as possible, remove as much atmosphere on top of it as we could.
Hmm.
Then, when we get to this peak point of buoyancy, um, to ignite the hydrogen in a focused jet, and then it twists the internal structure of the balloon. So you kind of think of a balloon; it kind of has an open arch kind of configuration with the ribbings, right? They kind of go out. The
Hmm.
idea there is to kind of spin it like a juicer, so that when it thrusts, it spins and keeps going straight up,
Hmm.
right?
But it's not reusable. Would
It
we be
would be
able to
reusable
take that?
actually.
Yeah.
Yeah. And then um, so yeah, once it gets up to the upper atmosphere, it delivers its payload. We designed it so that the bottom uncinches and it could parachute down.
As parachutes them. Hmm.
Yeah. And so the kind of trade-off there is I think it was I have to look it up exactly, but I think like a heavy Dragon rocket could take like 2,000 tons, or yeah, 2,000 tons of cargo to space. This system could take, I think it was 500 tons. So it is significantly less, but you could launch multiple. It would cost less because you're not building, it's not a lot of heavy metal. You're using just hydrogen, um, and it's reusable. So you can send multiple up a day. You could send four up a day and still get the same payload as one heavy rocket. And we're not we're not dealing with a lot of the same issues of using so much rocket fuel in the lower atmosphere and kind of getting past the harder point of breaking trajectory, of like breaking the exit trajectory. Um, and then the whole cloud kite system, that was, we really engineered that one because we were looking at how, like, kind of like I was saying, uncinching and becoming a parachute. We're looking at how can this like uncinch and become a solar sail, which is another type of a spacecraft, right? So it's usually a big thin sheet, usually a very incredibly thin sheet. It could be coated in like gold or something like that, and it's shot with like either microwaves or an electrical impulse or a laser to propel it. through space, and they can go pretty fast depending on how direct the laser beam thrusting it is. So it's like we thought, how do we get that solar sail type of um, spaceship, but make it come off the ground as a hot air balloon and articulate itself. So we looked at like the internal mechanisms for how it opens and stuff like that. Um, I do want to preference all of these things kind of sound like out there. We do have an engineer. Like I'm not an engineer myself. I'm an urban planner. We have a chief engineer of Project Human City who I regularly run my ideas and the briefs by, and it's usually him checking the math, and he's like, "Yeah, the math works." Like, or sometimes it'll be like, "No, that's not possible. You have to
But
try
sometimes the
again."
math works, the theory works, but then the engineers can't make it happen because they just
Yeah,
don't have the resources for it.
exactly. And that's why we built around the Art Cradle one, because we wanted to build the tooling capacity for the whole suite, right? There's something called Wright's Law, which basically saying the ability to produce technology is um, all ground in the infrastructure to produce the
Hmm.
unit, right? And so with the Art Cradle one leading it, it was how do we create the infrastructure for all of these advanced technologies? So one of the key things in the Art Cradle one is creating single sheet. Um, sorry, when I say single sheet, I mean single atomic sheet. So like one atom thin sheets of different metals. So graphene is one, yttrium, um, boron. There's a not boron. Boron's a gas. Let me look it up. I don't want to say something silly. I have a whole list of single sheet materials. Sorry. Put up. Uh, hmm, sorry. Okay, so there's definitely copper, graphene, um, ferrocopper, ferromanganese. Um, Tungsten is another one that we're looking at in particular because of heat distribution. Um, Yttrium, I mentioned, that one is more for computer chips. Uh, there's a whole suite of them. I have to get into it offhand. But yeah, I don't know. Maybe
Well,
we'll put in
that
a
may be
post note.
for a episode, part three of this episode, possibly.
Yeah, I should have had that up in front of me. I was focusing on some other topics in front of me. But yeah, um, the the whole thing about the Arc Cradle one was scaling up the capacity for single sheet electron materials because that it is the frontier of technology. It will allow us to do microscopic like nanorobots and microscopic technologies. But if we do it en masse and are able to do it more efficiently, then you can layer it and create actual like bars of pure minerals, right? If you're able to each sheet print them and then stack them together, you can get a more pure metal, which is a huge issue in a lot of these technologies, is refining out um, some aspect of the metal. If you do it en masse and you like try to um, refine a larger amount of metal, you're going to have a larger amount of impurities. So it comes from the
Hmm.
micro scale up so that we can remove the impurities. This will give more of the components super material status. So super materials are like high capacity um, transistors. They have very little resistance and electrical charge to none. Um, Great at heat retention and heat distribution, depending on which element you're working with. Um, and yeah, so it's just the foundation of getting to these more advanced models, right?
Mm-hmm.
Um, the like even for example, the built to last polymer to get to the point of being able to spray buildings with a graphene polymer will like out in the open world, that was a big issue because I was even thinking I'm like we may even have to have components to uh sorry, my
Oh,
tablet died.
oh, okay.
Um, but sorry, I forgot what I was saying. I was going to say, yes, the built to last polymer. So one of the issues with that is that usually when you are using chemical vapor disposition, or you're doing it in a controlled like environment in like a clean room, so that you're not getting other particles into um, like the liquid graphene or the graphene in the solvent before it dries and properly cures. Um, so even in that aspect, we're going to have to look at tooling of either an aerosol or like a brush with a heating element. Um, but overall, it's just like as we develop a control of manufacturing the single sheet materials in the first place, we're going to be able to scale the application of it in the real world. It's this is more of a tooling problem as opposed to a practicality problem. And that was the big thing in the Art Cradle one is to focus on tooling. Once we got the environment and the systems um, to a point where it would be able to do what we needed, all of the rest of the research and development would be into integrating new tooling into the chamber to manipulate the materials at that fundamental level and as they scale up. So
Mm-hmm.
what I mean by that is like one of the techniques we developed is called electromagnetic stitching. I mentioned that it's using the plate, a silicon carbide plate with electromagnetics under the plate. And then what it does is it has like these um, two cilia forks. That's what I call them. Like cilia model cilia is part of your um, there's a ton of model cilia in your body, but it's essentially allows chain reactions and the proper placement of molecules in your body. It's like these little amino acid branches that kind of look like a forked finger, like a Y shape. So the idea there was to replicate that with extremely thin copper wires and control the electromagnetic fields around both of these little forks. And so you have the base electromagnetic plate, and then you have the chemically deposited graphene or whatever metal you're working with. Then you're manipulating the electromagnetic field the um, under the material. You're directing the electromagnetic field very precisely with these two cilia pieces. And then it also had a free electron laser. So it's essentially you're kind of moving around the atoms. And then when you get into a configuration that you need, you shoot a electron in it to bind them. And then you continue like that as you stitch across the panel.
Mm-hmm.
So it's like using electromagnetic waves to align the atoms, and then the free electron laser is pumping in the appropriate amount of electrons at each intersection of electrical fields so that the metal binds as flat as we'd want.
Mm-hmm.
And yeah, so that was a big process. And so I did talk about most of the other things. that I
Hmm.
talked about. So the other thing was the covenant bond, which was the money that you had to hold to transfer.
Oh, like the Futurama.
Yeah, and that was
Yeah.
actually we designed that because not because of Futurama, but we designed it because of parents that steal their children's identity and financial fraud.
Oh,
Yeah, that was where I got the idea because I had been seeing a bunch of like stories on TikTok about stuff like that. And I
but
was
parents
thinking,
take identity.
yeah, where they like
Parents.
open credit cards and stuff like that out in their
Oh.
children's names before their children are adults and stuff like that.
Oh, oh
So
my God. Yeah.
so the idea of the covenant bond was until you're 18 and you make a covenant bond, you can't have credit or do anything with credit or basically do any of those financial transactions. And
Hmm.
it creates a way of ensuring the individual's financial freedom,
Freedom, yeah, and
right?
privacy.
And privacy.
So yeah.
So that you don't get like people can't manipulate your funds or your
Hmm.
resources. And yeah, so and then the vision massage was another one, which was the mask. The top layer was a complete suit made out of the mask. Um, Other things we also pitched. There's a lot of things we pitched.
No, but we did cover the mask part the last time. I'm pretty
Yeah,
sure.
yeah. The other thing we pitched was in like the whole vein of space mining. We were saying if we're going to get to the point of space mining, and this is going to create a population boom overall, and it will open up new frontiers. So then we started looking at if we're getting these massive amount of metals from space, we can start building intergenerational spaceships, like starships, to go to other systems, building massive ships in space. The plan actually had the moon being a kind of like manufacturing bay. And so the idea is you ship metal to the moon, we manufacture on the moon, build a ship there, and then you ship from the moon.
Hmm.
Um, but in that in particular, we developed something called space skin. And so space skin is a way of cladding spaceships so that you don't, so that we can basically live in space. Because as you know, we cannot, like most spaceships, they're still terrible with radiation, and you have a lot of issues with, exposure to space. Um, so it essentially was like you have a base metal layer and then a shielding layer, an insulating layer, and then a kind of like a tungsten tile mortar. So it essentially made like hex tiles where you have the outside metal components, and then inside you have so you have like a graphene layer, and then you have a water layer, and then you have a one-way fungal pore, which would be like a copper layer that allows water into the fungal layer, and then the fungal layer is there's a type of fungus that is growing in Chernobyl that they started studying, and the idea was to inoculate the plates with that Chernobyl fungus because what it does is it actually eats radiation, right?
Hmm.
So the idea was to make plates with radiation eating fungus in the wall so that as you're going through space and you're getting all that radiation, this fungal layer is eating the radiation as it's coming into the ship. There's other things like the shielding layer, but we'll get to it. Like there's other like shielding layers, just like metal shielding, right? So like a lead composite to reflect it. But then as you get farther into the ship, you have this fungal layer which is eating up all the excess radiation. And then the fungal layer is actually on a catalytic plate. So it's using the energy of the fungus as a battery. So as
Hmm.
the fungus is feeding on the radiation, the catalyst place is collecting the energy, and then it has a battery layer, and then the battery layer um, powers a plasma matrix as a
Hmm.
last line of defense from the outside, um, the outside radiation. And so we designed this as the an outer layer of spacecrafts. And then we also looked at something called electromagnetic torsion, which I kind of talked about before, which is kind of creating a circle within a circle and then spinning in opposite directions to create artificial gravity. And then that's like on the inside of it. Then there's like that's like the outer tile layer, and then there's a unified internal tile layer, which would kind of copy the same kind of fungus model, but instead you'd have internal mycelium, which would start eating the waste products that people on the ship produces. So the idea is the outer wall of the ship would eat the radiation that's coming in, and then the inner walls of the ship would eat the waste product that people are producing and have a layer of a fungal layer in the wall to help recycle systems. And yeah, so that has like a structural layer and then an internal mycelium layer. It has waste injection points, and then it has a condensate hydrogel layer, and then a topsoil layer, a growth layer, an air layer, with a one-way pour, and then a ceramic layer and a surface finish. So then in the spaceship, we'd collect all this garbage. Usually you get a lot of dead hair, dead skin, stuff like that in your spacecraft because there's nowhere to go. But the idea is that it would go to the walls, cling to the walls, and then actually end up feeding the walls. As opposed to just accumulating and having to be scrubbed out. Yeah, and
Well,
then
I've got one more question for you. Do you want to do a part 3?
I do want to do a part 3 because I was a little underprepared for this in that I should have brought up more details. And I kind of did want to talk about like the engineering philosophies because like I said, I'm not an engineer, but I don't think it's hard for people to engineer if you have a good understanding of like engineering principles. Like one of the things that I always look at when I'm designing something is the least amount of movable parts as possible, right? And that's a very good engineering maxim. So we can go through or have another episode and we can talk about these things of, if
We
you
can
want to.
talk about the like how is engineering limited, to implement the theories?
Yeah.
Like what exactly is limiting it? Is it resources? Is it money? Is it the funding? What is it?
Oh, for sure. Yeah, we could definitely look into that. That'd be a good episode. So I guess we'll have to wrap it up here.
Now this was Humans Talk, a project of civic thought and radical imagination. If something in this episode moved you, share it. Subscribe to your platform of choice and stay tuned for more voices, more questions, and more human ways forward. See you next time on Humans Talk.